Hello everyone, my name is Abdul Rahman from TMV LifeGrid. My project name is AquaAlert Boy. This is my team structure with Mr. Khurshid Amin as our team advisor. It is why in this era of modernization there is a high death toll of approximately 1,325 people being killed in the recent floods in Pakistan. Let me tell you the reason. Basically, these most of these people belong to the rural communities which did not receive early warning before the flash floods because existing monitoring systems are expensive and mainly cover the major rivers, and which makes it practically impossible to install this commercial flood monitoring system on each and every river in Pakistan, and leaving these rural communities beside the small rivers vulnerable to the flash floods. So we designed a solar powered floating buoy which detects the water level in the river and other weather condition, and sends the SMS alerts and initiate local sirens and the warning lights in case of flood conditions. So it works without any internet connection or grid electricity, saving the lives of people, protecting the livestock, and reducing rescue costs. This project is perfectly aligned with disaster and emergency technologies, providing a low-cost flood early warning system which is easy for the communities to deploy and maintain. So why we developed Aqua Alert was that in 2022 Pakistani floods highlighted the lack of affordable early warning system for the rural community, highlighting the major problem with the existing early warning system. So AquaAlert aims to bridge this gap by providing a low-cost community-on flood warning systems with significant social contributions, including early evacuation, protecting vulnerable groups, saving livestock and crops, protecting preventing school disruptions, reducing disaster recovery costs, and supporting disaster preparedness. So, what is the current situation? This is the small river in Pakistan with no early warning system because it was too expensive to deploy one. So this rural community is vulnerable to the floods and did not receive any warning, leading to the loss of human lives, injuries, and their crops were destructed, livestock losses, infrastructural damage. Their water was contaminated, soil eroded, and there was a major disease outbreak. Other than that, there were school closures leading to learning disruption. And currently, there is no affordable, localized, off-grid early warning system, which gives a need to the projects like AquaAlert. So, in simple terms, this project is a solar powered floating flood monitoring system that continuously measures the water level in the river and other weather conditions and automatically alerts the nearby communities before dangerous flooding occurs. So, how this will work? First of all, I would like to point out all the sensors and the communication modules that will be used. So for the power supply, we will be using a solar panel with a 12-volt battery. For the microcontroller, we will be using ESP32 because of its fast digital data transmission. GSM module will be used for the SMS, and radio waves will be used for the long range communication. And the ultrasonic sensors and the float switches will be used to detect the water level in the river with BME 280 and range gauge to detect the other weather conditions in the river. The GPS will be used to find the exact coordinates of where the buoy is placed. An IP waterproof enclosure of IP rating 67 will be used to make the body of the buoy, and concrete block with chain will be used as the anchor. So, how this all sensors and communication modules will calibrate? First of all the sensors and communication modules will be initialized, and the ESP microcontroller will take the reading from the sensors. It will take the reading from the float switches, which will be placed one above the other. When the water reaches float switch 1, it will be activated, sending signal to the ESP. And if the water level reaches float switch 2, it will also be activated, sending signals to the ESP controller. Ultrasonic sensors will be used to send ultrasonic waves and receiving it back to detect the water level. Now you must be wondering that why we are using two different sensors to detect the water level. This is because there is a possibility that any fault can occur in the sensors, or and debris or the waste in the river can cause the false reading uh, taken by the sensor. So we are using two sensors. So ultrasonic control microcontroller ESP32 will take the reading from the float switches and then the ultrasonic sensor and compare both reading. If both readings match, then there is no false reading. If they both do not match, then there is a false reading, and the main loop will repeat every 10 seconds until both values matches. So then it will take the reading from the BME 280 sensor and the rain gauge to detect other weather conditions. And after analyzing all the weather conditions and the water level by an algorithm, it will calculate the percentage risk of the flood. If there is no critical risk, then the main loop will continue to repeat every 10 seconds. But if there is a risk, it will send an output. ESP controller will send the output to send the SMS through the GSM module. If the SMS service fails due to because there is unreliability of the signals in certain areas of Pakistan or any other third world country, so it will use long range communication as an backup to send offline alert to the pre-registered mobile numbers, and it will also initiate buzzers and stroke. And once all the conditions revert to the normal conditions, our system will also revert to the normal monitoring. This is the picture of our prototype, and we have not placed it in the buoy yet because we are testing the each and every module to ensure its reliability. So this is the we were well aware of why of the over risk of the overheating of the batteries due to direct exposure to the sunlight. So we performed this experiment, and in which the maximum temperature reached was 38.5 degrees centigrade of the battery. So it is perfect for these types of application, and nothing was wrong. And this graph was obtained after performing the experiment to check if the ESP microcontroller and the alert status was working accurately. So this is the schematic of how all the sensors will give input to the ESP controller. Again, this will give the output if there is an high risk to all the communication modules and the alarm. This is the 2D AutoCAD image of our project with the front view explaining how and where all the components will be placed, and the side view telling the length of each and every component, making things more clear. Moving towards the commercialization potential, there is a great commercial potential of our project with the target customers of local government NGOs, humanitarian organizations, and disaster management industries agencies. We have great commercial potential because there are some great benefits of our project in comparison with the competitive systems. Because our project is low cost, solar powered, no internet is required, easily maintainable, and it has scalable deployment. It is also sustainable because it has open source software allowing the and user to change the default setting to meet their own needs, and future AI integration. It has local maintenance, training, low cost replacement parts, and upgradable firmware. Moving towards the target audience, which we have divided into three categories. The first one is the primary audience, including riverside communities, farming communities, government disaster agencies, and the secondary audience includes humanitarian organization, telecommunication organization, and development funders. Tertiary audience include academic institutions, policymakers, and urban planners. It has many benefits and impacts. Most of them related to the benefits for the people. It saves lives, protect property, livelihood protection, and reduce the economic loss, mainly because it provides an early warning of the flood and accurate warning to the people, which also build the community trust. Because we have installed a two-tier alert logic using two sensors, it has equal access for all because one person does not have to be literate to understand that there is a flood warning. It has environmental benefits mainly because we use it is a solar powered device with zero carbon operation and low material footprint and off-grid deployment. It has significant contribution to the daily life, like 24/7 passive monitoring without any human operator, SMS and siren alerts, and emergency coordination for the authorities to deploy their rescue team faster. Our projects, moving towards project schedule, first we reviewed the existing literature and finalized our budget. Then we confirmed the components based on their delivery time, availability, and benefits. Then we designed the circuit using the Tinkercad software and assembled all the hardware components. Then we wrote the sensor reading and data processing code, implemented two-tier alert logic, and programmed all the communication modules. Then we calibrated all the sensors together and conducted water tank rising and falling tests, tested long-range communication as a backup plan, and verified siren strobe SMS alerts. Then we documented our final project report and analyzed sensor accuracy. Moving towards the strengths, which I have already mentioned. So the major weakness of this involves require GSM coverage for the SMS battery replacement after years. There are many opportunities for this project, including government adoption, NGO partnership, international disaster program, expansion using AI, and export to the flood-prone areas like Sri Lanka, and Bangladesh. It has threats mainly due to the extreme vandalism in the rural areas. And other than that, competition from the commercial system, network outrages, and the severe disasters.